G'day, I'm Dave and I'm going to have a quick chat about the scale of the universe. I'm going to start locally in our galaxy. I'll probably start even more locally and start right in our solar system. I'll start in the centre. Now if I was to scale down the Sun 10 billion times, I would have something roughly this size. Now I'm talking not much bigger than a cricket ball. I'm talking about 15 centimetre diameter. Now someone's come in and obviously drawn a really accurate Sun for me. So if the Sun's this size, I'm going to talk about comparative distance and relative size. So first of all, the Sun's this size, 15 centimetres in diameter. At this scale, the Earth would be approximately the same size as a ball in a ballpoint pen. Now, if we're talking distance, unfortunately I can't draw the Earth and the Sun at this scale on this whiteboard. So the Earth would be across the road, it would be in my neighbour's yard. The distance from the Sun to the Earth at this scale would be 15 metres. So now we've covered size and distance. This 15 metres represents 150 million kilometres, or 1 astronomical unit. 1 astronomical unit is the average distance that the Earth is from the Sun during its orbit. So now we've got Earth and the Sun. It's still a massive number, 150 million kilometres. Now this scale, 1/10 billionth for size, 15 metres to Earth. Let's go out to the furthest planet. Let's go out to Pluto, which is not a planet, but let's go out to Pluto anyway. Pluto is orbiting at 600 metres from the Sun. That means at one end of its orbit, 600 metres, at the other end is 600 metres. That's covering an area of 1.2 kilometres at this scale. Now within that 1.2 kilometres, there's an Earth, which is the size of a ball in a ballpoint pen, in size 1.2 kilometres. It's so insignificant. Now, this is just our backyard. This is our solar system. If we were to venture out of our solar system and go to the closest star, so at this scale, it would be the same as me walking from here in my living room in Canberra to Perth. Now that's just the closest star at this scale. So no matter how far Pluto is away, at 600 metres, it's nothing compared to how far away we are from the closest star. Now, what that means is when I'm looking at Alpha Centauri in the night sky, it means I'm seeing something relatively this size in Perth from Canberra with my naked eye. Now, that's just phenomenal. I can see something this size in Perth with my naked eye, without any sort of visual aids. Okay, so that's from our star to the next star. Now let's venture out of here now. We'll leave our own backyard and we'll go to what is referred to as our local group. Now let's put us in the centre of the local group. Our local group is just a close group of stars. Now these stars are all moving randomly compared to each other. So they're all moving in different directions at different speeds. And it seems a little bit random. But to put the size and the distance into perspective, let's just say we're moving one direction and there's another star that's moving at an average speed comparatively in our local group. Let's say 70,000 kilometres. Now we're talking faster than bullets. Now this is in our local group, so it's one of the closest stars to us. Let's say we're moving towards that star and it's moving at a tangent of 90 degrees at 70,000 kilometres. That is such a fast speed that it's hard to comprehend, but that distance from here to here is so vast that we won't, in our lifetime, notice that change in position at 70,000 kilometres an hour, because this distance here is so vast. Now, this is just our local group. We haven't even broken out of our local group of stars. Now, let's go bigger. Let's talk about the Milky Way galaxy. Now, you'll have to forgive my artistic talent. It's not the greatest. Okay, so first of all, inside the Milky Way galaxy, there is 100 billion stars. Now, that's such a big number that it's hard to understand, but just to write it down, we've got 100 billion stars, or 1 times 10 to the 11. Now, just to get an idea of how big a number that is, if you were to sit down and you could visually see every star in our galaxy, and you could count them, and you were counting them at 1 star per second. Now, if you had no breaks, no eating, no sleeping, no dying, and you were to count every one of those stars, 1 per second, it would take you 3,000 years. There's a huge amount of stars. Now, this is just the Milky Way galaxy. Let's draw a dot, and let's say within that dot is our solar system. So it's about 1/5 of the way in from the edge of the Milky Way galaxy. And if this whiteboard represents the whole of the Milky Way galaxy, this dot, let's say it represents 1/10,000th of the whole of the Milky Way galaxy. Now, just to do a quick calculation, 1 times 10 to the 11 divided by 10,000 means that in this dot that represents 1/10,000th of the whole of the Milky Way galaxy is 10 million stars. 10 million stars. Now let's just go back to the local group. Our closest star, at the scale that we were talking about at the start, takes me the same time as it takes me to walk to Perth to get to. Now that's just 2 stars. Now in this dot we've got 10 million stars. These numbers are just astronomical, literally astronomical. So this is just our galaxy. So we haven't even broken out of our galaxy. Now from one side of the galaxy to the other side of the galaxy, in distance, is 100,000 light years. That means that if I was over here at this side of the galaxy and I was to manage to see something over here through a telescope, I would see them 100,000 years in the past. That means if they're looking at us right now, they're seeing us 100,000 years ago. So they're not even seeing humans. That's how far back they're looking, just across our own galaxy. Now, let's get out of our galaxy. From here we go to a local group of galaxies. So we've got a local group of galaxies. Now what happens is there's clusters of galaxies and clusters of almost no matter. Now, remembering that from there to there, across our Milky Way galaxy, is 100,000 light years, that means that the whole observable universe is 14 billion years in any direction. Now, 14 billion years, light years, in any direction. So anywhere we see, the furthest observable point from there is 14 billion years in the past, which we can't see further because that's further than time itself existed. This scale is amazing. It's astronomical. I can't get over it. That's the best I can explain the scale of our universe.